Hello everyone, welcome back. This is Calculus 2. So in this video, we're going to talk about the cylindrical shell method. This is another method to find out the volume of solid of revolution. So far, if you remember, 2.1 and 2.2, we talk about slicing method and disc method and washer method. So just briefly review, disc method, you are going to rotate the given function about x-axis or y-axis so that you are going to find out the circle cross-sectional image. And then we are adding all the image, all the area of the circle so that you can find out the volume, so that we are using pi r square. If you are taking, the integral in terms of the x-axis, everything should be related to x. If you are rotating the function around y-axis, then you are going to take the integral with respect to y variable, right? So that was a disc method. You're going to find out the cross-sectional image, which is a circle. The difference between washer and disc, for washer method, we are going to have two functions and you're going to rotate two functions at the same time so that there is a cavity, there's a hole, between two functions because you're rotating them at the same time. And we are looking for the between area, between volume. So therefore, same thing, pi r square, the large area minus a smaller area. So you have to find out which one is a large height and then minus from there. So same thing, if you're rotating it around x-axis, everything should be related to the x variable. Otherwise, it should be y variable. So we talk about those are two disc method and washer method to find out the volume. Now in 2.3, I'm going to show you the last method. Same goal. We're going to estimate the volume of the solid of the revolution. So we call it as a cylindrical shell method. So what is the difference this from disc and washer method? Take a look at it. So the idea is very, 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 very brilliant. So we know what the cylindrical shape look like. So it is going to be something like that. This is a cylindrical shape. And then let's say I want to find out, this volume of the cylindrical shape. Okay. Well, if you want, you can think about the disc method because if you're rotated, you're going to find out many infinite number of the circle cross-sectional image. So if you're adding them up, you can find out the volume. But here I'm going to introduce another perspective. What if we are going to adding, there's infinite shells, right, inside of this cylindrical shape. So it's like a shell, right? Or you can think about like onion. You're gonna peel out each peel, or then you're gonna collect all the peels and adding them up. You're gonna have entire onion shape, right? So same thing. You are keep adding the surface area of this cylindrical shell infinitely, many times. You are going to have the volume of this cylinder, right? So that's why the name is a shell method. You're keep adding the first shell, the second shell, third shell infinite times, then you can find out the entire volume of this cylindrical shape. Okay, so it's not that complicated. What is the formula to find out the volume of the cylindrical shape? It's a 2 pi r h, right? So this is the volume to find out one cylindrical shell. So 2 pi, this is the formula, and r represent the radius of the circle, h represent the height. So you can think about this area, right? So therefore, shell method, so this is a little bit of proof. So another approach is you're going to have the next area, next shell minus the next smaller shell. Then you're going to have the between. You're going to keep going, this work infinite times, and you can find out the total volume of the cylinder. So 2 pi, and then you're gonna have the radius, and then times the height. So therefore, this is going to be very simple. I'm gonna write down the shell method from this idea. The shell method, you have a two formula. Why? Because you might be rotated x-axis, and you might rotate it y-axis rotation, correct? So 2 pi, we're gonna take the integral a to b, and then remember there's an x represent the radius, and then you're gonna have a height function, and then we are going to take the integral. So I'm gonna write that. This is the radius, and this is the height function. And then 2 pi r times the height, exactly that's the volume of a cylindrical shape, and then integral implies you're adding the same, shell of the same volume of the cylindrical shape infinitely many times from the Riemann sum. So we are going to take the integral so that you can find out the volume of the entire cylindrical shape, right? So here is a different thing. For the disc and washer method, if you remember, the x-axis rotation, y-axis rotation, for each rotation was really corresponding to x and y variable, correct? If you rotated around x-axis, you took the integral with respect to x variable, but here is a different thing. If you are taking the integral, to find out the cylindrical shell volume, it's going to be opposite. That's a different thing. So if you're taking it, if you rotate it around y-axis, you're gonna take the integral with the opposite variables. That's a different thing about shell method. So therefore, if you rotate about x-axis, you are going to take the integral y variable. Does it make sense? So y is going to be radius hy dy. That's a different thing. So same thing. This is represent radius, and this is going to be the height. It's going to be opposite. So x-axis rotation, you're going to take the integral with respect to y variable. If you rotate it around y-axis, you're going to take the integral with respect to x variable. So that's a different thing. So same thing, if you're rotated around x-axis, you're going to have infinitely many cylindrical shell like this. Okay, so that in this time, we are going to find out the radius of the circle on the y-axis. That's why, right? So this is x-axis rotation. Where is my radius? On the x-axis, on the y-axis. That's how we are taking the integral with respect to y. If you rotate, right? So this is a rotation around y-axis. Where's my radius of the circle? On the x-axis. That's why we're taking the integral with the opposite variable. Okay, so let me write down that sentence. That's what I'm saying. Integral and revolution are perpendicular relationship, as you see in this image. So we are going to use this shell method in this 2.3 chapter. Okay, I hope this concept, it's not that complicated. Okay, I'm going to bring this image here so that you can see the radius, right? The radius on the x-axis, and the radius is on the y-axis. So that's why, although you rotate it around x-axis, you're taking the integral with respect to y. Although you're rotating it around y-axis, you are taking the integral with respect to x variable. So this is the formula we call shell method. So I'm going to make a copy. Okay, and make a little bit smaller. So this is the shell method. Are you okay with that? Yes, so Keep in mind, this is the last method to find out the volume of the solid shape. So let me show you the, from the definition from the textbook one more time. So again, if you are going to rotate the function around x-axis, right? So let me write it, rotate the function about x-axis, you're gonna find out the radius of the circle on the y. So y represent radius and hy represent height. So 2 pi r height, that's gonna be the volume formula. Same thing, the second function is going to be when you rotate the given function about y-axis, the radius of the circle is on the x-axis. So that's why this is going to be the radius and that is going to be the height. So that's the formula we already wrote there above, so that you will find out this formula again in the textbook. Okay, so let me write down, because this is the opposite, right? Many people confuse. If you rotate x-axis, everything is a respect to y variable. If you rotate y-axis, everything respect to x variable. It's a perpendicular relationship. One more time, I'm going to write it. Shell method integrates along with the coordinate axis perpendicular to axis of rotation. Okay, so that's the different characteristic from disc and washer method. Okay, so you got this concept. I'm gonna show you a couple example how we can apply this shell method to find out the volume. So before we're gonna get there, let me just copy this, because we're gonna see this formula a lot. So let me copy. And let's take a look at example 1. Okay, I'm gonna paste it here, our formula. So this is the formula. It's a little tiny. So I'm gonna actually separate this to formula. Cut and paste. So here. And then I'm gonna delete this. Okay, this is our shell method. Better? Okay, so this is a shell method formula. So let's read the question. Define R as the region bounded above by the graph of f of x equal to 1 over x. So the function is given, f of x equal to 1 over x function, and below by the x-axis over the interval 1 to 3. So the range is given as well from 1 to 3. Find the volume. Yes, we're going to find out the volume of the solid of a revolution. You're going to rotate the given function around y-axis. Okay, so let's take a look at the image. So this is the given function f of x equal to 1 over x. They're going to rotate this function about y-axis. So this is a 2-dimensional image. If you look at the 3-dimensional image, it's going to look like that. So what happened is, when you rotate this function around y-axis, you're going to have many infinite number of the cylinder. So one cylinder here, next one is here, the next one is here, right? So there are infinite number of the cylinder when you're rotating this function around y-axis. So what happened is, we're gonna use the shell method, and then this is a rotating y-axis. So the first formula, we're gonna use it. So the v equal to 2 pi from A to B, x, the radius of the circle, times the height. This is when you're rotated around x-axis, right? And then let's plugging in all the given information. So equal to 2 pi, we have the range from 1 to 3. And then x is a radius. We don't need to change anything. X is a radius unless they are mentioning about the radius of the circle, we don't need to change anything. This is kind of like fix the radius of the circle. Depending on your x variable, your radius is going to be changing. So x itself is the radius of the circle, right? So keep it. And then height, this is the function. Depending on the x, you have a different height, right? So the function is going to be 1 over x. One more time. This is the radius. This is the height. And then we are going to take the integral with respect to x variable. Pretty much that's it, right? And then we're gonna simplify, cancel. So 2 pi 1, 2, 3, 1 dx. When you take the integral this part, 2 pi x 1 become 1x from 1 to 3. So therefore, we're gonna subtract 3 and 1. So 2 pi 3 minus 1, 2 pi times 2. I got you. So the 4 pi, this is the answer. That's the volume of this cylindrical shape. So we just use the shell method. Are we okay? So that's another approach to find out the volume, of the cylindrical shape. So we're gonna keep practicing this shell method. So I hope this is getting better and better. And let me just bring this formula, copy. Ready, ready, ready? Let's take a look at number 2. So I'm gonna paste it here. So this is our shell method formula. All right, so find the volume of the solid obtained by rotating about the y-axis. And then this region is between those two functions. So let's think about it. What is going on? So this function, a little up and down, this is the function y equal to 2x a second minus x to the third. And y equal to 0 is literally talking about the x-axis. So they're gonna rotate it, this function around y-axis. So you have to imagine what would be the three-dimensional space look like when you rotate them. So this is going to be something like that. This is going to be the cylinder, and they're going to be a little bit larger and larger, larger. So there's a cylinder when you rotate it. So we're going to use the shell method to find out the volume of this solid shape when you rotate about y-axis. So we're going to keep using the first one, v equal to 2 pi from a to b. X is the radius of the circle, height dx. This is y-axis rotation. So we have to think about the radius and height. So this is going to be the height function, because depending on the x variable, you can find out the height. If x is 1, you can find out the height, x equal 2. So we know the height function, and the x is a radius. We don't need to change anything. So here, 2 pi x times height function, 2x a second minus x to the third dx. Okay, and then let's think about the inner ball. So the inner ball, do we have it? No, we don't have it. So we're gonna find out the a and b. So from, actually in the image we know from 0 to 2, but let's calculate it. We're gonna say those two functions are equal. So let's say this is f function. Let's say this is a g function. So we're gonna find out a and b where f and g equal to each other. So 2x a second minus x to the third equal to 0. So I'm gonna find out the common factor. So 2 minus x equal to 0. So that is gonna be 0. This is gonna be 0. So x equal to 0, x equal to 2 exactly. A to b is gonna be 0 to 2. So from 0 to 2. So we set up the shell method when you rotate the function about y-axis. Now what? We're gonna take the integral. So expanded it. 2 pi, 0 to 2, 2x to the third, x to the 4 dx. So when you take the integral, It's going to be 2x to the 4 over 4 minus x to the 5th over 5, and then from 0 to 2. So when you calculate this, I'm going to just make it smaller. So this is going to be 2 pi x to the 4 over 2, x to the 5th over 5 from 0 to 2, and then let's subtract. So 2 pi 2 to the 4 over 2 minus 2 to the 5th over 5, and whatever, it's going to be 0. Because when you plug in 0, everything is a 0. So this is going to be 2 pi 16 over 2, 32 over 2. So when you calculate this, actually 32 over 5, the denominator is 5. So you can plug in into decimal. So you can find out the decimal. As a fraction, you will get 16 pi over 5. So that's the volume when you rotate this function about y-axis based on the shell method. So there's infinite number of the cylinder, right? And then you are adding all the summation of the cylinder's shell so that you found out the volume. That's a 16 pi over 5. Does it make sense to you? So take a look at that. Okay, so I think we are getting better and better. I'm going to do a couple more examples. So let's take a look at it. Example 3. So I'm going to keep utilizing the shell method formula. So here we go. So we have function given f of x right there, 2x minus x to the second. And from 0 to 2, you're going to rotate it about y-axis, and you have to imagine the three-dimensional image looks like that. Ooh, but when you rotate it, you have infinite number of the cylinder here, like this. The next one wider, right? So there's an infinite number of the cylinder when you rotate it about y-axis. So same formula, the first one, right? So v equal to 2 pi from a to b. X is a radius times height dx. This is where you rotate the function about x-axis. So nothing is special. We're going to plugging in every given. From where to where? 0 to 2. They say from 0 to 2. The radius of the circle is x. Height function is given. 2x minus x to the second dx. So simply you're going to take the integral. So let's quickly do it. So what happened? 2 pi 0 to 2, and then I'm going to expand it again. dx 2 pi. And I'm going to take the integral 2x to the third over 3, x to the 4 over 4 from 0 to 2. So plugging in 2 and 0, 2 times 2 to the third over 3, 2 to the 4 over 4, and minus 0. So 2 pi 16 over 3, 16 over 4. So you can change it to decimal, or you can leave it as a fraction. So that's the volume when you rotate this function about y-axis, which means you keep adding the infinite number of the cylinders shape. Each cylinder. All right, so we are doing awesome. So I'm going to do 2 more questions so that you have a better confidence. So let me keep going. Number 4. I think number 3 and 4 was a really similar question, but let's take a look at this one. Okay, this is exactly what I want to do, something different. So we have the Q, that's the region according to this function, the G function. And then this is represented by Y variable. So G of Y equal to 2 times the radical Y, and from 0 to 4, 0 to 4. Find the volume. You're going to rotate this function around x-axis. So this is a 2-dimensional space. When you think about the 3-dimensional image, this is a cylindrical. What happened? When you rotate this function about x-axis in this time, your cylindrical is going to be, what happened? Horizontally. So you have here, the next one is here. So you're gonna find out many cylindrical cylinders horizontally. So in this time, we're gonna use the second formula because we rotated about x-axis, right? So this is x-axis. So volume 2 pi C and D, y, everything is represented by y variable. So this is, you rotate about x-axis because the radius of the circle exactly on the y-axis. So let's plugging in. What are you guys gonna do? We have 2 pi, and they say from 0 to 4 height, and then y is a radius. It's not gonna be changing. And then thank you, make sure that the function is already modified with respect to y variable. So you don't need to change anything. This is already converted to the y variable. So the height function will be 2 times the radical y and dy. Does it make sense to you? So you have a radius of the circle, you have the height function. So take a look at it. We have all the information. We're gonna take the integral. So this means what? I'm gonna bring constant to the front. So 4 pi, 0 to 4, y times the radical 4 dy. And you can simplify y times the radical 5. Everybody knows that radical y is a half exponent. So 4 pi, 0 to 4, y times y to the 1 over 2 dy. According to the exponential property, you can adding the exponent if you have the same base. So that means 4 pi from 0 to 4, y, 1 plus 1 over 2 dy. So that it is going to be 0 to 4, y to the 3 over 2 dy. Now you're gonna take the integral. Got you? Yes, so we're gonna take the integral. So it is going to be 4 pi y 3 over 2 plus 1 divided by that exponent 5 over 2 from 0 to 4. Okay, simplify. We're gonna flip this one, bring it up. 4 pi times 2 over 5 and y to the 5 over 2 and from 0 to 4. So basically 8 pi over 5, y to the 5 over 2, 0 to 4, and you're gonna plugging in. So 4 minus 0. So let me just minimize a little bit. Okay, and then 4, actually 8 pi over 5, 4, 5 over 2 minus, everything is a 0 because a 0 to whatever is a 0. So you're going to calculate this. 8 pi over 5. This is 2 to the second. That's a 4. 5 over 2 cancel. 8 pi over 5, 2 to the 5th. So if you calculate it, this is going to be 256 pi over 5. There we go. So you can find out the volume of this cylindrical shape when you rotate about x-axis. So remember, this is important shell method formula. Okay, so let's take a look at the last question. So maybe you have a question at this moment. Professor Ben, you know what? Can I use a disc method? Because when I rotate x-axis, the cross-sectional image is anyway circle. Can I do that? Yes. So if you are using disc method and shell method, doesn't matter which one you're going to use because our goal is the same to find out the volume. You're going to get the same answer. So that's what I'm going to do in the last question. Many people ask me, Professor Ben, cross-sectional is a circle. So yes, you can use a disc method. So let's take a look at the following question. I'm going to show you two different methods as you're thinking disc method and shell method. Do they really give us the same answer? Yes. So let's take a look at it. So I'm going to make a space here. So, all right. So find the volume. Okay, we're going to find the volume of the solid obtained by rotating about the x-axis. And then here is the given function. So let's take a look at it. Y equal to x a second here. Y equal to 0 right there, x equal to 0 right there. x equal to 4. So this is the reason we are going to rotate it about x-axis. So if you think about that image, you're going to have this image, something like this. So you're going to have a little like a small cylinder, the next small cylinder, cylinder, or you can simply find out the cross-sectional image. So we're going to do two different methods. Can I use disk method? And can I use a shell method? So let's see, compare. Then we're going to do this. Disk method says, we know that we are adding all the cross-sectional images, which is circle, to find the volume. That's what the disk method, right? You're going to have a cross-sectional image, adding all the circles, images, or shell method. It's a little bit different. We are at all the area or shell of cylindrical shape, cylindrical solid to find the volume. So they have a different meaning. More specifically, shell method, you have like the cylinder shell, and then you're gonna adding the next cylinder shell. You keep adding, you're gonna keep overlap the next cylinder solid, and you're gonna find out entire solid. So they have a little bit, they actually have a different approach. They're not equal. One is adding cross-sectional image circle. Second one was we are adding all the shell of cylindrical solid infinitely. So the formula is also different. If you remember, the formula for the disk method, V equal to pi from A to B, f of x, pi r squared dx. And then if you are rotating about x-axis, this is x-axis formula. They're matching, correct? For the shell method, if you're rotating the x-axis, it should be perpendicular. So the opposite to pi, A to B, y, and then you're going to have a height, dy. This is what you are rotating about x-axis. I'm going to just minimize it a little bit, right? So this is when you're rotated x-axis. So we have a different formula, but to find out the volume of this shape, both methods gonna work, right? Because they're gonna talk about the same, the volume. So I'm gonna do each one. So let's see what happened. So we're gonna solve the first question using the disk method. So V equal to pi from where to where? We already know from 0 to 4. So we're gonna stop there, 0 to 4 on the x-axis. And then the height function is going to be x to the second. Depending on the x second, you have a different height. So the x second to the second dx. This is the disk method. So I'm going to keep simplifying. So let's take a look at it. So here, v equal to pi 0 to 4 x to the 4 dx. Now I'm going to take the integral x to the 5th over 5. There is a pi 0 to 4. So we're going to do 4 minus 0. So basically pi over 5, 4 to the 5th, and whatever 0. So if you calculate it, it is going to be 4 to the 5th, 0 to 4, pi over 5. So the first answer gives us, gives us the volume of this solid shape is going to be 1024 pi over 5 using the disk method. So let's do the shell method, okay? So to find out the shell method, the given function should be represented by y variable. So let's take a look at it. We have a volume equal to 2 pi And then we have to think about it. Everything should be with respect to the y variable. So we're going to step by step. So I'm going to make a little bit of separation. So 0 to 4, it's on x-axis, right? But this is going to be the y variable. So your radius of the circle should be on the y variable. Are you following? Because that's the cylinder's radius. So to find out that, so to convert it, the inner ball, so we know y equal to x a second. So 0 second, comma 4 second, this is going to be on y-axis. So therefore, we're going to use a 0, 16. That's the inner ball for the shell method. So here it is going to be 0 to 16. And then y, it's a radius. We don't need to change anything, but hy we need to change because we also have the function is what? Y equal to x a second. We're going to solve for x. So if you put the radical on both of sides, you will get radical y equal to x because they're going to cancel. So that means f of y will be radical y. Are you okay with that? So that's going to be your f of y or h of y, your new the function with respect to y variable. Okay, so that's the height, but think about it. The cylinder is going to be something like this, horizontally. And then this is the height though, right? So depending on the, y variable, now you have a different height of the cylinder. So we have to a little bit think about it. We have height function, but then you are not going to infinitely, they actually stop here, x equal to 4, right? So therefore, it's a little bit complicated, but the height function, okay, we good. This one, we convert it to the radical y. So the f of x was x to the second, but now f of y equal to radical y, but you stop right there, correct? So the thing is, height function is going to be 4 minus radical y. That's a little bit tricky one. Okay, so think about it. This is the radius of the circle. This is the height of that cylinder, which is from here to here, so that we know the function is a radical y, but you stop there 4. So 4 minus that height is going to be the given height, we can utilize it. So by thinking this work, this is a little bit of work, in the shell method, and we're going to take the integral. I'm going to bring what we just set it up here. So v equal to now 2 pi from 0 to 16, y 4 minus radical y dy. This is what we're going to do. I'm going to expand it, v equal to 2 pi 0, 16, 4y, y times the radical y, so dy. If we just simplify, so this means 2 pi 0 to 16, 4 pi minus y times y to the 1 over 2 dy. One more time, 2 pi 0 to 16, 4 pi. This is, y is a 4 pi. It should be 4y, right? 4y, and then y, we have invisible 1 plus 1 over 2, that is a 3 over 2 dy. So let's take an integral. So 2 pi 4y second over 2, y 3 over 2 plus 1 divided by 5 over 2, and we have 0 to 16. So if you simplify, this is going to be 2y second minus this one, 2 over 5 flipped, y 5 over 2 from 0 to 16. So now you're going to subtract 2 pi, 2 times 16 second, 2 over 5, 16, 5 over 2, and minus 0, all because we have 0. So once you calculate this, 2 pi, 2 times 16 square, 512, 2 over 5, 16 to the 5 over 2, you will get 1024. And then you're gonna simplify this work. You should get 2 pi 512 over 5, which is a 10 to 4 5 over 5. Check it out. Which is, ooh, we have the same answer. So that's what I'm saying. Sometimes this method is a simple because across the sectional image as long as it is a circle. Shell method, sometimes it is useful depending on the question. So I will show you when shell method is more useful. I will actually show you in the next video. So in this video, I just want you to practice how to utilize the shell method and where this idea came from. Think about it. So make sure this is very interesting and important topic, right? So far, we talk about the disk method. With one function, there's a missing pi. Washer method with 2 functions. And then shell method, you have infinite number of the cylinders shell, and you're adding. So that's the different thing. And then this washer method, x-axis, y-axis exactly corresponding to each variable, right? But the shell method is perpendicular relationship. If you rotate it, opposite, y, dy. So that's a different thing. So check it out, 2.1, 2.2, 2.3. Each unit is talking about different method. And in the next video, I'm gonna continue to talk about 2.3 shell method. We're gonna do more challenging question, okay? So in this video, if you understood those 3 methods, and how to use it, that's great. So keep going to read the textbook and complete question 2.3. I will see you in the next video soon. Bye-bye.